Welcome to this project. This is an automated car parking system using Arduino. Key concept. This project is an automatic car parking system using Arduino. It includes an entry and exit gate, controlled by a servo motor. A vehicle is allowed to enter only if there are available parking spots. The system uses an RFID scanner to verify access card before entry. A sensor will detect whether a car is entering or exiting, and the system updates the number of available space accordingly. An LED display shows the current number of free parking spots, and if the parking is full, the gate will remain closed, even if a valid card is scanned. The main component it is including RFID scanner, LCD I2C, infrared sensor, a servo motor, capacitor, and ultrasonic sensor. About the circuit, RFID scanner. The RFID scanner has 7 pins that need to be connected to the Arduino 2, of which are connected to 340 voltage of power supply, and the other is the ground. Note that it needs to be connected at the 340 voltage pin of Arduino and not the 5 voltage pin, since the 5 voltage pin is too high and it might damage the RFID module. Now, the remaining 5 pins are connected to the Arduino from pin 9 to pin 13. At the 9 pin is an RST or reset pin. It's tasked to reset RFID module, typically used during the initialization or the setup part. Connected to 10 pin is SDA or the slave select. Basically, what is that is to tell the module when to listen to the SPI device. Moreover, at the 11 and the 12 pin are the MOSI and MISO respectively. MOSI receives data from the Arduino and vice versa. The MISO sends the data from the module Arduino. Finally, the SCK or serial clock pin are connected to the 13 pin. Its job to provide clock signal to synchronize the data transmission from SPI to qualify on SPI service, short for serial polypolar interface. It's referred to MOSI, MISO, SCK, and SS. Next, the LCD I2C. The LCD screen is fully called LCD I2C. Without the I2C, it will need a minimum of 6-pin control LCD. With the help of L2C, it requires only 2 pins to be able to control the LCD screen. There are 4 pins to be connected, 2 of which are 5 voltage power supply and the ground pin. The remaining 2 pins are SDA and SCL. SDA are connected to the A4 pin. Its main job is to transfer data between Arduino and I2C in bidirection. SCL is connected to A5 pin. Its job is to send a clock signal to I2C device when it should read and write. The infrared sensor. For the infrared sensor, there are 3 pins to be connected, 2 of which are 5 voltage and ground pin. The last pin is called out pin, which have 2 IR sensor. The IR1 is connected to the 2 pin, and IR2 is connected to the 3rd pin at the Arduino. The servo motor. The servo motor has 3 pins. 2 of them are 5 voltage power supply and ground pin. The last pin is connected to the 4th pin at the Arduino. The pin will control the servo at which angle it should rotate to. The capacitor. The capacitor is placed next to the power supply and ground pin of server, since the server uses too much voltage and voltage. Thus, the voltage may dip and other components. Even the server might not work properly without capacitor. Therefore, to prevent other components from voltage shortage, we insert the capacitor next to the server supply and ground pin. Ultrasonic sensor. Ultrasonic sensor have 4 pins to be connected at the Arduino. 2 of them are the power supply and ground pin. The other 2 pins are trigger and echo pin. Trigger pin job to send the ultrasonic pulse to the object, while the echo pin job is to receive the reflected pulse. In addition, we have two ultrasonic sensors for the trigger 1, echo 1, trigger 2, echo 2, and is connected to 5, 6, 7, and 8 pin respectively.
This is the initialization part of the program. The wire and liquid crystal I2C are the libraries to control the LCD screens. The servo library is to control the servo, and the last two included libraries are to control the RFID module. First, we initialize the LCD variable at the address 0x27 with 16 column 2 rows. I will tell you where I got the address of 0x27 from. Next, RFID variable were created with the parameter slave select pin at 10th pin and reset. Card UID variable are the UID that we allowed to access the parking lot. Next, we keep the pin number of the component to the variable. For example, the infrared sensor 1 is at pin 2 and so on. Slot 1 and slot 2 tracks whether the slot is currently available or occupied. Slot available is the variable to track the availability of the parking lot, whether the parking lot is full or not. Car entering and exiting are variables to track whether the car is trying to exit or trying to enter the parking lot. Lastly, we initialize the servo. Regarding the question of where I got the address of 0x27 from, I went to the file and I click on examples, and then I go to the MFRC522 and goes to the dump info, and I run it and upload it to the Arduino Uno and look at the 0 monitors, and it will shows you the address in hexadecimals of your card UID. Next is the setup part. I attach the servo to the 4th pin and write it to 160, meaning that the gate is closed. Next, I pin mode the component that I initialized variable in the previous part to be input or output. For example, IR sensors will be input as always. Trigger pin should be output since it sends out the pulse, and echo should be input since it receives the reflected pulse. Then I initialized the LCD screen, and initially I had it print welcome on the top row and parking lot on the bottom row. Then I initialized the RFID module. To clarify more, SPI is to start the communication between the SPI in the RFID. Before going into the main loop, let's break down the function that I created. Lot state function receives two input, slot 1 and slot 2. If slot 1 is true, then it will be printed out on the top row that slot 1 is occupied, otherwise it prints out empty. This applies to this slot 2 as well, but now on the bottom row. Next is the distance function. Distance function will be utilized with the ultrasonic sensors. It receives two inputs, the trigger pin and echo pins. To accurately measure the pulse, we first stop the ultrasonic sensors from sending out the pulse and delay it for 2 microseconds. Then we let the sensor send out the pulse and then stop it after 10 microseconds. Then we use the pulse in function to calculate the duration of the echo when the echo pin stays high, or in the other word, meaning that the duration that the echo pins receive the pulse. Then we calculate the distance and then we return it. Next is the UID scan function. The first while loop will look for when the card is being scanned, and it must be valid UID for it to break out of the loop. Then we convert the UID byte into hex code for an easier comparison. Then we loop through each hex and compare the card UID variable in the initialization part. If it match, then we will print out aloud and return the value to the main loop. Else, we print try again and return false to the main loop. Okay, now I'll be explaining to you the main loop to this program. The first if statement checks that if the car is now in front of the infrared sensor 1, it will goes into the if statement and will now change the variable car entering to true. And now we will check the slot availability of this parking lot. If the slot available is more than 0, which means there's still a slot left, then we will let the customer scan the card to further goes into parking lot. However, if the slot availability is 0 or less than 0, which is impossible, then it will shows at the LCD screen as parking full. And Now let's continue with the scanning the card. If the card is valid, if the card that the customer is trying to scan is valid, then it will open the gate where my servo.write 70, which means open the gate and reduce the slot available by 1, and we will set at the LCD screen to print gate open. Now we'll encounter two while loops, where the first one will check that the car have passed the gate already. That's the first while loop, and after we exit that first while loop, we encounter into the second while loop, where we check that the car have left the infrared sensor 2 into the parking lot. And after that, it will close the gate, and we will write at the LCD screen as gate closed. Next part is the next if statement checks whether the car is exiting the parking lot. If the digital read infrared sensor 2 equal to low, which means that the infrared sensor 2 is triggered, then the LCD screen will be printed car exiting, and the servo will be opening the gate, and the slot available will be +1. The LCD screen will print gate open, and will encounter the two same while loop, whether it will check whether the car have passed the gate already. That's the first while loop. The second while loop will check whether the car have passed the infrared sensor 1. If it's already passed, then it will break out of this while loop, and it will continue into printing the LCD screen as gate closed, and the servo will close the gate at the line myservo.write 160. The last part of this program checks the state of the parking lot, and that will be shown on the LCD screens. Now the first if statement checked the distance of the object in front of the ultrasonic sensor 2. If the object or the car in front of the ultrasonic sensors 2 is below 10 centimeters, then the slot 2 variable will be set to true, which means that there is a car in front of the ultrasonic sensors, which also means that there's a car parking at this slot. Otherwise, then the slot 2 will be set to false, which means that there's no cars parking at this slot 2 currently. The next if statement is the same as the previous one. Now we will change from ultrasonic sensors 2 will be changed to ultrasonic sensor 1 instead, and now the slot 2 will be changed to slot 1, and it's just a repeat of the same if statement. And then we will just show it on the LCD screen by calling the function lot state with the passed in argument of slot 1 and slot 2.
The system is now active. The LED screen displays a welcome message indicating that the parking lot is ready for use. Now the car is timed to enter the using an invalid card. The system rejects the scan, show try again on the screen, and keep the barrier closed. The driver scans a valid RFID card. The system modifies the card and lifts the barrier gate, allowing the car to enter. An ultrasonic sensor detected the car and updated the number available parking spot on the LED display. A second car arrived, scanned a valid card, and entered the parking lot. The system detected the vehicle and updated the display accordingly.
The third car wants to enter, but the parking lot is full, so the barrier does not open. The LED display shows parking is full.
Now, car 1 and car 2 exit the parking lot. The ultrasonic sensor detects the departure of the vehicle, and the system automatically updates the number of available spots. The LED display reflects the new available, reopening lot for the future vehicle.